I won't promise. In fact, we won't be all data scientists by the end of this presentation. Uh, but at least my hope is that if you are not, and if you are still wondering what exactly does a data scientist do, and if you are a Power BI developer especially, and with Fabric, if you're wondering how are you going to use data science in your Power BI workflow, well, you are at the right place and attending the right presentation. So my hope is by the end of this presentation, you'll at least learn about the workflow. You'll at least learn about some of the terms, terminologies, some of the techniques, and then more importantly, what Fabric has to offer when it comes to data science. There is a big, I guess, misconception about data science and what it means that you have to be a mad data or mad scientist with a lab coat and a PhD to be able to do a lot of this stuff. And we'll try to um, demystify all of that stuff. And I can show you that even with just a little bit of knowledge which you already have, if you can further that knowledge and skill a little bit more, you will be able to enrich your Power BI solutions even more with Fabric. So. But the topic today, data science on Fabric. My name is Sandeep Pawar. I'm a senior Power BI architect at Hitachi Solutions. Hitachi Solutions is, I guess you probably know about Hitachi, the Japanese conglomerate, the big company. We are one of their smaller companies. We focus exclusively on the Microsoft data stack. We are a Microsoft Gold partner, and anything and everything that Microsoft has to offer, be it Synapse, Azure Databricks, Power BI, Power Apps, Power Automate, Azure, yeah, you name it, and we have it. I work as a senior Power BI architect, and as the title suggests, I focus solely on Power BI and Power BI related projects. My background, however, is not in data. I was a researcher. My background is in mechanical engineering. My degree is in mechanical engineering. I did my master's in mechanical engineering, did a lot of statistics. That's how I got into data science. So uh, compared to most folks, I think people try to go from BI to AI. I started with data science and then loved the BI aspect of it. Loved working with the business and then solving business challenges with data. And so moved on to doing more BI stuff. Since Fabric, I launched um, my own blog at fabric.guru. Definitely take a look at that. I write anything and everything related to Fabric, mostly on data engineering, Power BI, Direct Lake, data science, Spark. Anything that I learn new about Fabric, all the cool experiments that I do, I write about all of those things in at fabric.guru. As Greg mentioned earlier, I'm super active on Twitter at Pawar BI, easy to remember. So if you are on Twitter, definitely follow me. So to stay up to date with everything. The agenda for today. I don't have any slides. In fact, this is my second slide, and the two other slides I just have a picture on top of that. It will be demo heavy. We'll be looking at stuff, looking at the data, and that's about it. The I'll first give a quick introduction to Microsoft Fabric. My assumption here is that because all of you come from Power BI background, it's impossible pretty much that you don't know anything about Fabric. You've at least heard about Fabric, but I'll still try to level set here and give you an introduction of Fabric and why it's important. For the topic today, data science platform, what the Fabric has to offer on that, I'm going to break it into three different aspects of that. The first is the data exploration and analysis piece of how Fabric data science platform will help you. Second is the report enrichment and augmentation. We'll look into that. And the third is the machine learning aspect of it. And this is what I was talking about earlier, that most people, when they think about data science, they think about machine learning, creating the predictive models, and then creating the churn models, creating the classifiers and regression models and all of that. Which is part of data science, but we'll look at how you can do that in Microsoft Fabric. We won't necessarily be able to go into super details about it. But what I want to do is in Microsoft Fabric, you have the ability to create experiments, track those experiments, log these machine learning models. So I'll show you how exactly that works, and we'll do that with a very, very simple example. So it's very easy for you to understand and digest it, and at least at a high level, understand what the workflow looks like. If you are, for example, collaborating with your data scientist colleague, then you'll at least be able to understand what goes on behind that. And if it is something that you find interesting, then at least it will be able to help you to go in a direction. The focus here will be learning about the data science platform itself rather than data science. It's almost impossible to obviously cover the entire data science in an hour. So instead, we'll focus on what data science will offer you as you create your Power BI reports. What are the possible solutions? What are the use cases? And more importantly, just improve your overall general awareness of the whole process and understand the workflow. As I mentioned, this is not a session where you'll be able to learn data science, machine learning, or Python, but at least learn about that a little bit at a high level. I don't expect any of you, to know anything about data science. No experience is required. But I think it's a good assumption at this point that you at least know Power BI. So if I use a term like semantic model, you know what exactly I'm talking about. And then obviously hopefully you've had some experience with just in general data analysis and such. So Microsoft Fabric, I guess, yeah, I mean, you must have heard about it, right? But in a nutshell, what Microsoft Fabric does is instead of having all the different pieces that Microsoft has had in its bag of tools with Azure, Synapse, Azure Data Factory, Azure Machine Learning, Custo, Azure Data Explorer, Power BI, and all of those different things, Microsoft has always had that. But the challenge has always been that all of those technologies, they resided in their own islands, right? And someone like me, who is a consultant, where we have a team of consultants who work on a typical project with many of the large companies. It's a bunch of us come together. A data engineer comes together, but data engineer, a data scientist, BI analyst, and architect. All of us come together. We create an architecture and how to piece all these different things together, and then finally give a solution to the customers. From customer point of view, that's not what they ask for, right? What customers are looking for is a solution. They don't care how you get there. Obviously, yes, I mean, they care how you get there, but they would like you to get there in most cost effective manner, with as fast as you can, and without having to build a lot of different custom solutions, and which is exactly where Microsoft Fabric fits in. Instead of a platform as a service, this is a software as a service. So, which means everything is already pre-configured for you. Everything is all pre-wired for you. You do not have to provision an Agile SQL Server. You don't have to provision and then create linked services. You don't have to go through all those hassles of putting all of these things together. It's already done for you on one single platform, and which is what exactly Microsoft Fabric does for you. So at the heart of Microsoft Fabric is a one lake. One lake, you can think about it as a giant OneDrive. but it is a data lake. And there are certain things that it does for you, mainly being reliability, scalability, performance that OneDrive cannot offer. The one lake is essentially just a data lake plus a few more other things added to that. And then on top of that, so OneLake is the storage part of it. And then Microsoft has added all these different compute engines. So Data Factory being one of them for orchestrating all your pipelines, moving data around. Data engineering, obviously, to create your data warehousing solutions, which includes both data warehousing as well as Spark SQL Engine, data science, which is what we're going to talk about, Synapse real-time analytics, Power BI, and Data Activator. Interestingly, I don't know if you've seen Data Activator, but it just lit up in my personal tenant today. So I'm going to take it on a ride sometime this weekend. So very excited for that. Uh, the way I guess all of this works is if you have tracked how where the industry has been going over the last few years, is with a typical traditional warehousing solution, we always had the compute and the storage linked together, right? If you need to scale one, you could not decouple the two. You had to scale everything up to a certain extent. With Fabric, because OneLake and OneLake is the storage part of it, and all these computes surrounding it, all of these are decoupled. It means that all these compute engines, they access the same data lake in one lake, and it keeps one copy of the data, and you can choose any engine that you want, that you have experience in the job that you're looking to achieve, to choose any of those compute engines and then create the solutions based on your experience, based on your requirements, and not having to worry about configuring any on all of these things. So let's take a quick look at what exactly the Fabric looks like. So if you go here, you go to Fabric essentially just by going to app.powerbi.com, just like how you typically go to Power BI. But the only difference that you will see is in the left-hand side here. You have all these different persona switches. Very up at the top here is Power BI, which functions essentially just like Power BI, and you wouldn't even know the difference if I didn't tell you that this is actually Fabric. But then on top of that, all the compute engines that we just talked about, be it Data Activator, Data Factory, Data Science, Data Engineering, all of these reside there. And they operate on top of this one lake, which is where your data resides. The overall orchestration, how it works and differs from how we have been using Power BI, right? So it all depends. If you are coming from a background where maybe in your company you have all your data in on-prem, maybe Oracle, SAP, or SQL Server, the typical workflow looks like you have your data, you pull that data maybe via Gateway or Azure Data Factory, and then land it into either Power BI or Data Lake. And then from there, you take it into Power BI directly in the data set, or you create a data mart or a data flow, create your semantic model on using that data, and then create the report, and then surface that report, distribute that report to your Power BI users. In case of a Fabric, we achieve the exact same thing. The overall orchestration also looks like exactly the same, or at least similar. But the only difference is we have all of these different things on one single platform. So which means the data engineer can go and then open Power BI, work on that data. Data scientist has access to the exact same data as the Power BI developer is using in Fabric, and all of that. So you can all collaborate together seamlessly without having to switch between different tools, technologies, and platforms. So that's a little bit about Fabric, and I'm sure you probably already know what all it entails. So we'll get right to the data science part of it. But before I do that, what I want to do is maybe start with something that you're already familiar with, something that you've seen many times, and then we'll try to see how, with data science, you will be able to create different solutions or more enriched solutions. So this is a sales and return sample report that Microsoft has published, right? And I got it directly from their website, and you can go to the documentation, the MS Talks page, and you'll see that it's right there, right? So they have the whole semantic model built here. We have all the tables, the DAX written, and the whole thing. This is sales and returns. So as the name suggests, we have sales for company. I don't know what company this is. It doesn't look like Adventure Works or anything, but yeah, so this is a company, and in this report you will see the sales data and the returns data, right? If you are a Power BI developer, and if you produce something like this, your boss would be very proud of that, right? But I mean, this looks nice. I don't know if I'll ever be able to create something as nice as this. Pretty sure about that. I mean, this takes a lot of effort to do that, right? Lots of bookmarks and really nicely nice themes and colors and everything looks really glitzy and very sexy. But as a Power BI developer, mostly what we do is do something like this. We add all these aggregate measures. And if we look at the measures, let's start with the first page here. So we have net sales, so which is a sum, then units sold, which is a sum, net sales by date, so which shows you kind of a trend, then by category, which is again an aggregate data, but broken down by different categories, by products as well as by stores. Then you go over to returns. Again, the same theme repeats. You have the some sort of an aggregates and percentage, and all of those things. So as a Power BI developer, we mostly focus on that aggregated insight, right? What are those? What is that sum? What is that percentage difference? What is year over year? What is quarter over quarter? Then this versus that. Maybe in some cases averages, and in some cases percentiles. And that's mostly what we focus on, and that's in part because the users are also used to that, and that's what they also always look for, right? They want that number. So what I wanted to do was look at this from a data science perspective, that if I were to put my data scientist hat on, how would I approach the exact same thing, especially now that I have the tools available in Microsoft Fabric to be able to look at this data using Fabric. Okay. So as I was going through this data, by the way, at any point, if you have any questions, I don't see the chat, but at any point, Greg or Tina, if you see any questions, please feel free to stop me. So if I go to this page over here with the return rate, what caught my attention here is this looks nice. This is, let's say, maybe somewhat of an advanced feature in Power BI where you can do a what if analysis, right? That you create a what if parameter. I have stores, the net sales, the forecast, and the profit. And the idea here is that the user should be able to slide this and adjust what is the overall return rate. If I'm a business user, an executive, and if I want to see if I reduce the overall return rate by a certain percentage, then what would be, how much would that add to my bottom line? And the idea is really nice, right? This is something that you give the user the ability to interact with the data, and then hopefully they'll be able to glean something from it, get some insights, and then make some business decisions based on that. So which is great, which is what we want. But now let's take a look at the exact same data with the exact same scenarios and understand if we can learn about this a bit more if this was done correctly, and if we were to do this using data science, how we would do this differently. As I'm going through this, I'll use Python, and please don't focus on the Python code itself. I'm not a programmer by any means. I know Python. I use it every day for data analysis purposes, but that's about it. I don't use it for creating uh, programs or softwares or anything like that. So focus on what I'm doing. Focus on the concept and focus on the intent behind the analysis rather than the code itself. Okay. So what I did was I have this data already, right? So I extracted all of this data, and then I went over to if I were to analyze this data in the previous before launch of Fabric, the way I would do this is I would go to a Jupyter Notebook. If you've not heard about the notebook, it's an open source software, Jupyter Notebook, and you're able to run different programs like Python, R, even PySpark. In a notebook like this, it's very interactive, and you're able to get your output right directly inside the notebook. So I would typically ingest that data or analyze this data in a Jupyter notebook, but we don't have to do that anymore. What I can do is I can go to, I've already created a workspace here. So I'll go to Portland, and then I have already created a lake house. And lake house, before I do that, let me switch over to the persona that I want to be in because I'm ingesting the data. So I'll go to data engineering, and what I want to do is create a lake house. And lake house, as I, maybe I'll show that. And if I create a lake house here, you can think about the lake house in this case as a container in your lake. In your data lake has two sections: the unmanaged section and the managed section. Unmanaged section here is the file section where you import your data. So what I did here, I just went ahead and then upload files, and then uploaded the data. So I've already done that to save time, which I have right here. Let me delete this so as not to confuse us here. But if I go to my Portland Lakehouse here, you'll see that I've already imported all of this data right into my notebook or right into my lakehouse with all the tables that are in that Power BI report. When you are working with Power BI, this is, or when you're working on a Power BI project for using Fabric, this is how it will typically look like. You'll have data either in the file section or in the table section, depending on where you are at and what you are doing. In this case, this is just raw data that I'm importing right into here for further analysis. And then what I can do is just like how I have the Jupyter notebook here, I can go right ahead here, go to data science and start a notebook, which I've already done that with the notebook, which is data science for data science in Fabric. Let me zoom in a little bit more here. Okay. So we want to analyze this data. And like I said, what grabbed my attention was the return rate, right? So I want to understand what exactly is this return rate, and how can I understand that a bit more. We saw that that return rate was broken down by different stores, right? So let me read the data in here. So I'm just importing this data using Pandas, which is a Python library, so directly from the data lake here, from the lake house here. So I import that data, which is what this looks like. Again, don't focus on the code itself. I'll walk you through the code and wherever possible, but nothing fancy here. This is just data that exactly how what it would look like when I have that in Power BI. Now, the difference often when you are working in a notebook is because we are not creating a dimensional model in a notebook. I need that fact table, the sales fact table. And since I'm analyzing the data by store and the product, I need to join it all together to create one wide table, which has my sales data, my transaction data, my product as well as my stores, right? So which is what I'm creating here. So I create my sales with everything. And lastly, what I do is just create a group by on top of that. Let's skip this part. Yeah, a group by on top of that, where I say just group by that data and then give me just weekly sales, because what we saw earlier here was based on weekly sales data. So on this x-axis is weekly sales, and then give me the overall amount. So just sum that by each week for each store. So let's try to look at that and see what it does. The very first thing that why I do is I calculate what is the mean return rate. We saw here that we calculated the net return, and then we are using the return rate percentage. But on this report itself, it nowhere shows what is the actual percentage return rate, right? So let's go ahead and calculate that. I calculate both the mean and the median, and the difference between the two is that if your mean and the median are the same, if your then your data is fairly symmetric. In this case, I calculate the mean return. It's about 39%, and the median is about 36%. So that's my first clue that the two are not the same, which means there is some uncertainty in the data. There is some spread in the data that I need to look at a bit more. So which means there is some distribution. So let's look at just the distribution of the data. And what I mean by distribution is if we were to take, for example, if I were to go back here, and if I were to take for each sales or rather store for each week, if I were to calculate what is the return rate, get that, and then count, let's say 25%, how many times 25% has occurred, right? I count that, create that histogram, smooth that out, and understand what that distribution looks like. So that distribution looks like something like this. Now, this is not something that we typically do in a Power BI report, or when we do something like this when we are analyzing the data in Power BI. Why? Because it does not exist in Power BI. You cannot create a histogram, you cannot even create a histogram in Power BI, let alone a density plot or a distribution plot like this, right? From this, so the first observation that I had earlier was this difference between the mean and the median, right? Very basic statistic. The second observation that I have here is it's not symmetric. If you were to look at a typical bell-shaped curve, it's nice symmetric curve, right? It's very you have the peak right in the center, and then it's very symmetric on both sides. In this case, it is not symmetric, and not only that, it has two humps, right? So which tells me again that there is first that my data has some pattern in it. Two, there is significant pattern within the data that I maybe need to look at. This is percentage return rate for all the stores, right? And then why do I have two humps here instead of one single hump, one single peak over here? So let's try to understand that a bit more. So what I did was, next, I looked at the stores and then break the overall distribution down by the distribution by each of the store. So this is for all the stores, and this is for just this is breaking it down by further stores, each of the stores. Well, maybe this explains why we are seeing the two humps. So if I see right here, this line right in the center here, about 35%, and then I have this is a box plot, that I have some stores that are further to the right of this line, and then some stores that are left to this line. So which means the next insight that I get from this is not only the overall return is not symmetric. Second, there are stores that have different rates of percentage return. If we were looking at aggregated data like this or aggregate just by stores like this, not something that we would easily be able to identify just by looking at that aggregate, right? So that tells me that maybe there are two different types of stores. That one that have very high return rate, and then the other that have low return rate, which is what we saw here. Further, if I break it down again, the just this portion, but by the density or the overall distribution of these percentage return rates, it it um, it confirms my hypothesis. So what this is showing me is I have again right in the center is this my let's say the average. Then there are some stores that have this hump on the left, and then some stores that have hump on the right. But interestingly, not only that, each of those stores again have two humps. So if I were to focus on just one, this green one here that's called Salvus, it has again a hump on the here and a here. So which means first we found out that there are two different types of stores based on the percentage return rate. And then within each stores, there is possibility that we have maybe potentially another categorization depending on what is being sold, perhaps that has different rates of percentage returns, right? So, which is what I did. I isolated this one store and further broke it down by the products, and then look at what this look like. And we can see it is all over the place. And the reason why I'm showing you that, and you might be wondering why I'm blabbering about all of this stuff here, is because there is a huge misconception that when you are doing data science, you are creating all these predictive models. So data science is not just about creating these predictive models, but data science is about understanding the patterns in the data, understanding the trends in the data, understanding the signals in the data, and identifying what is signal and what is noise, and then creating solutions, creating insights based on that. Now, all this stuff that we just went through, I've been using Power BI pretty much since it was launched, and I've never worked on a single project where, unless I'm working on a data science project, where I would go to such a length to understand the data. Because as soon as I start working on a Power BI project, my mind, at least that's how I work, completely shifts focus to creating my semantic model, avoiding that many to many relationship, that bidirectional relationship, using the best practices. How do I use the best practice analyzer? How do I create my most performant DAX? How do I create my bookmarks and all of that stuff? And very little focus is given to the actual understanding of the data, and a lot of focus is on actually productionizing that report, the report aspect of that, which is often lost. And this is where I think Fabric really helps us as Power BI developers, because now you have the tools necessary to be able to dig deeper into the data and understand these patterns. An argument is often made, well, this is not for Power BI users. This is for data scientists, for people who understand statistics, and people who have a lot of expertise in this thing. But as I was going through this, I was intentionally recapping the insights and the things that I was doing. I used only two statistical principles here. One was mean and median, and then two, just looking at the overall distribution of the data. There was no hypothesis testing, there was no p value calculation, there is no null hypothesis, there is no power law analysis, and all of that stuff that a statistician typically looks at. All we are trying to do here is understand the signal in the data, understand the patterns in the data. So now the question is, having done all of this, how does it change the Power BI report that I've created? Or would it even change the insights that I've found from here just by analyzing the data? And the insights we found were that there are various stores which have different percentage returns. Within those stores, we have different products who likely dominate how those percentage returns are for that particular store, and each of those products have different percentage returns. Another factor that I've not talked about here, but and we may probably skip that, is not only that. If I look at the overall, if I look at it on the trend level, you can see their trends differ as well. So there is a time component to that as well, which we'll have to look into that. So again, going back to the question, how does this now change the Power BI report that we've created? Would it even change? Yes, it does. The first one is that we have lumped all our stores together, right? I would identify or segregate these two stores based on, excuse me, based on the insights that we just got. There are probably two different types of stores just based on the percentage return. Second, when we look at this percentage return rate, the idea here is very clever, that we give the user the ability to just change this return rate, right? Slide this, and then it should dynamically update my forecast and derate my overall return based on that. But if we think about that for a moment, exactly what this slicer is doing, I'm entering the percentage, 13%. That same 13% is getting applied to all the stores, which is and the assumption here is that we will be able to do that for each single store on equally. And then two, probability of 13% is as same as probability of us reducing it by 48%. So if you are a business user, and if my current return percentage return rate is, let's assume it's 20%. If I were to ask you, um, as a CFO, tell me how likely it is that you'll be able to that return rate will go up to 70%, you'd say that's nuts. That's not even possible, right? On the other extreme, if I were to challenge you to say lower that return rate all the way to 4%, would that be possible? You would say that's nuts. So that's not even possible. Why? Because we know from business that if my average for that store is 20%, even with my best efforts, maybe I'll be able to lower that maybe a couple of percentage points or maybe double digits, but it's not going to go all the way down to a single digit, right? And that hypothesis is confirmed by this analysis as well, that it is actually, let's go up here. When we used that what if analysis, what if parameter slicer, we essentially said that the probability of each of those percentages is equal. So which is this flat line over here. Whereas from our analysis, we know that there are two humps here for this store based on maybe two different products. So we should be maybe very close to where it should be, very close to this peak over here, this or this. And not only that, it should change based on the store and then maybe possibly by the product. So how would you do something like this in Power BI? In the past, it was not possible. I have written a blog post where you can create these distributions using DAX. Very challenging. You can do lots of different things with it, but still very limited with M and DAX. So this was not even possible for to even consider doing something like this in Power BI. But now I have the ability to access the same data that you're going to use in Power BI with the notebook. So which means that I can now analyze this data. I can build a model on top of that. And it could be something very, very simplistic where I take for each of this a simple distribution, which is we already have here. Take this distribution and do something what's called as a Monte Carlo simulation. Now, I'm not going to get into how to run a Monte Carlo simulation here. If you go to my blog, I have a presentation, an hour-long presentation I did on how to run a Monte Carlo simulation and do that. But the idea there is instead of using a deterministic value of 48%, what I'll do is I will assign a probability distribution to each of these different stores, create simulations, number of different simulations, simulate it like hundreds of times, 100, maybe even 1,000 times in some cases, and then create scenarios based on that. That how likely that this store, Pyram store, is likely to have a lower percentage return versus high percentage return, and then create scenarios based on that. And then once I have all those values, I can just save that back to my lake house here, and then get the insights and then import that into Power BI as either as part of my Power BI dataset, add that to my Power BI dataset, and then import that, or directly to the delta table that's created in Power BI as a part of that dataset directly. So which means all of this, which was not even possible, is now possible for you. And this is exactly what I mean by creating insights or identifying insights. Now, there are different ways of identifying these insights. So, what we just looked at is just understanding the distribution and the uncertainty in the data. You could possibly maybe look at like what we did down here. We could possibly just look at the scatter plot or do some clustering analysis, which is possible in Power BI as well. And I think, if I'm not mistaken, I think the first, Greg, correct me if I'm wrong. In fact, the first presentation that I did here at Portland Power BI User Group was actually based on the AI visuals in Power BI, where we
It
covered how to
was.
do, yeah, clustering
It was.
analysis and all of that. So known techniques, right? But if you look back at that presentation, you will know that those techniques are super limited. There is not a whole lot that you can do with those. It has its own limitations. Now we don't no longer have those limitations. Obviously, Power BI in that case is just clicky, drag it, drop it, right? You click on a button, and then you are able to get those insights or create those clusters. In here you'll have to learn Python. It's a learning curve, but not something that is difficult. It's like I said, I'm not a Python programmer, I'm not an R programmer. I know just enough Python for data analysis, and which is all you need. An argument is often made. In fact, if any of you are on Twitter, there is currently a thread going on that this is not for your typical um, BI user or a business user. And I completely disagree with that. Yes, I mean, a typical business user who just wants to create a very simple analysis and not go to this extent, um, they won't they won't want to learn this, right? That's not their full-time job. But somebody, a data analyst, whose job is to identify insights and then provide those insights to create to the decision makers, they have not gone to this length just because they have not had the tools to do that. If you can learn DAX, if you can learn DAX, you can learn Python or pretty much
Mm.
any language in the world, right? That DAX is probably the hardest thing that you can learn in terms of programming and everything. So it's not difficult.
Sandeep, how much do you
Yeah.
think the Fabric Copilot's going to actually help with DAX? I know because every DAX is so, married to the model, we're all pretty skeptical.
Hmm.
I know you've probably got some insider insight.
Yeah.
And are we
Um,
gonna, is that going to help us at all?
Um, yes and no, because I guess one is because you still have to know what questions to ask, right? And then whatever question it gives you, if you use that as a starting point, then it is helpful. If you use that as a truth that this is what I'm going to use, then I doubted that it's going to help you. It will get better, I mean, compared to the Copilot that we have, I think if you use Chat GPT, GPT-4 especially, that thing is awesome. If something like that comes in Power BI, and I'm pretty sure it will, right, with their collaboration with OpenAI, if something like that, as potent as that does become available, then I'm very hopeful about its chances. But um, I mean, we've had the question and answers and narrative and all of that for a long time, right? With GPT-3, but it wasn't as awesome. Now, to your interesting question here about the second, maybe another way to think about this is um, maybe with the LLMs and Gen AI, generative AI, maybe you don't need to learn a whole lot of Python either, right? If you know the question that you are trying to answer and you pose it correctly and give it enough context, it will, in fact, generate all the code for you. In fact, it does that right now. I have um, yeah, I'm writing a blog post. In fact, you can turn the Fabric notebook into a co-pilot using Jupyter AI, where it in fact understands the data frame as well that you have loaded in your notebook, and you can directly ask questions, generate codes, and all that. So I think that will be super helpful. Um, and I know Fabric also has a lot of co-pilot features that are in the pipeline, which I'm very excited about. Okay, the second thing that I wanted to a little bit touch upon here is again this notion that with data science you're trying to uh, create predictive models. Another thing is that Power BI has tools that are available inside of it. You use that, but you may not necessarily be using that correctly, which is where again Fabric data science will platform will help you. So for example, I see this forecast that's created over here. This is a weekly forecast for this predicted net sales, and I see the forecast that's created right over here. It looks sort of accurate that it's jumping up and down, and the forecast that Power BI created in this default report, it looks about that, right? It just qualitatively speaking, it sort of makes sense. But is it correct? If you were to give this report to your CFO, and if he were to make certain decisions, business decisions based on this forecast, would he be making the right decisions? Well, you can we can use the notebook and the data science platform to learn more about that, and which is what I did. What I did was I loaded that exact same data and then created the forecast. And this is what the forecast I created. Now you'll say that, well, the forecast that I saw here in Power BI, this looks much more accurate than the forecast that we see over here, which is just a straight line. But that's actually not correct. The reason why Power BI created this forecast is if we look into this a bit more, if I go here and then go to forecast, you see that the seasonality here is 5 points, which is incorrect because this is a weekly data, which means the seasonality should be 52 points, not 5 points. I didn't change. 5 points was the default that was applied in this report. So I'll create an apply. Now you see it drops significantly and then jumps up. So is this correct? We don't know. It does not look correct anymore. But if you know a little bit about how power forecasting in Power BI works, it uses an algorithm which is not suitable for creating weekly forecasts. Because think about it for a little bit for a bit here, right? We have this data. There is no seasonality in this data. Yes, it peaks right over here in January, and then it peaks here in June. but there is no repetition. We don't know what happened in 2018. We don't have enough information for that forecast to even create robust and accurate forecast. So Power BI spits out some numbers which are complete garbage, but with the data science or with the notebook, we can at least validate that and then make sure that if it is wrong, right or wrong, which is what I did here. And this is, even though it does not look like, this is the best forecast that we can get quantitatively and qualitatively for the data that we have available. If we wanted to create a more accurate forecast, we would have to have, because this is a 1 year worth of data, if we are trying to project out for another 6 months or so, or maybe 3 months or so, we need to have at least 2 or 3 years worth of data, twice or three times whatever the seasonality of the data is, to reliably say this is what the forecast is, and you should trust that forecast. So this is actually the best. It gives us the trend. So qualitatively speaking, goes down, goes up, and what this is showing is what has happened in the last 6 months or so. I am projecting out that it will keep going in this direction. Just like what we talked about with the Monte Carlo simulation, you would do the exact same thing. I already have the forecast here. I can take this forecast and then save that forecast to the lake section here, or to the delta table, and then ingest that directly into Power BI as a part of my overall orchestration. And which is what the orchestration I was trying to show earlier, that you will ingest your data into the lake house. You will use a notebook to gain insights from that data. You'll save your whatever insights you've gotten to the lake house and then into Power BI. Now, another aspect of this, which is where I think most of you will probably benefit from, is excuse me, not even using this to um, to predict anything or create any new data. You can just analyze your data, just like how I did that here. Um, you can analyze the data, and then you can share this notebook with your colleagues with your comments added. So I can go here and then I can say, I can add a markdown cell here to say, hi, Greg, please take a look at this, and this is interesting, right? And then I can add my comments here. I can add my comments here. I can drag and drop and images here. I can drop links here. In fact, I can create a whole table section here, or table of contents here, so that the user who you're sharing it with, they have some navigation as well, that you can in fact lead them to each of those sections. And plus on top of that, you can highlight it, and they send say comments, new comment, and say, Greg, see this. And when Greg goes here, he can, in fact, let me go down here, and then I'll have to add another one.
It's pretty nice that they took, kind of the same concept of commenting in like reporting, right, all the
Exactly.
way to the back end,
Correct.
engineering piece of this.
Correct. And then this is, um, when you click on it, if you see, it actually jumps to those each of those sections. So it is
So
context aware as well.
there's no
So
bookmarking, it's just going to the comment.
yeah, it's going to the comment directly, and then you can see that. And once you've read this, you can go here and say resolve this thread, and it will go away. It will resolve that thread, and you can still see all your comments and everything. They don't yet have like tagging somebody, but that's coming. So I cannot go Greg here, but I know that's coming. But that will be available. But this is another interesting thing about this whole notebook thing, that think about it. This is where the enrichment part comes in, that I was talking about. First is just exploration of the data. And then second, the augmentation or the enrichment of your reports. This is additional piece of insight that you are offering to your business users. They can go here, things that are not possible to do. Maybe your business users, they don't care about all this distribution and all of that stuff, right? You still give them this part of it, but then you give them the report so that if they do have questions and if you want to highlight what that thing is, they can still go to the notebook, open that notebook, and then take a look at all the insights that you have offered in that notebook. Okay. Any questions so far before we jump into the next section?
Fernando did just actually post a question. Can you only use Python or is it possible to use R?
Oh, yeah. So in fact, if you scroll down here, you have PySpark, which is Python. You have Scala, you have Spark SQL, you also have R. So to answer Fernando's question here, you can technically use R, but it is Spark R. So as a R user, you won't even notice any difference. In fact, you can switch between different languages. So I can go here percent R, and it becomes R. If I do percent Python or PySpark, it becomes PySpark. So that's how you would change that. You can also change it from here. So if I'm right here and then go from Python to R, you can do that and it will become an R cell. You can take an input. So you can take an, if I'm doing this analysis in Python, and then I want to switch over to R, you can pass that data frame from Python to R, do your rest of your analysis using R, and then again get that data back into Python and then continue doing that. Now, I wouldn't do that in production use cases, but in fact, for forecasting is a great example of that. But compared to Python, R has a very rich ecosystem of forecasting tools and libraries. So you would do your entire analysis in Python and then switch over to R, to your forecasting in R, get those results, go to Python, and then save all your data to one lake. Anything else, Tina?
It looks like that was it.
Okay. Okay, so that was, if we were to again go back here, we talked about the data exploration, how the Fabric data science platform will help you with the exploration. We talked about how the report enrichment and augmentation will help you with to create more insights. And the last remaining piece here is the machine learning. And just so that I'm aware of the time here, Tina, how much time do I have left here?
We're pretty open-ended. We usually go until as late as 7 o'clock.
Okay, so that would be 9 my time. Okay,
Sandeep, we
yeah,
would
that's
stay on until midnight for you. So you just let us know how much fuel in the tank you got.
Okay. Yeah, okay. Yeah, so next, what I wanted to show you was we did not look at the entire suite of tools and features that are available in a data science platform yet. So I want to show you what exactly is available in there. So when you go to, as I said earlier, these are different these are different personas and the persona switcher here. So if I go to data engineering, you'll see that and if I say artifact here, Alex is not going to be happy. So I'll say item, all the items that are available here for you for that persona. So we have Lakehouse, notebook, Spark job definition, a pipeline, and a notebook. If I switch over to data science, however, you will see the notebook, which is what you use for all the coding and all the analysis. Plus, on top of that, you have two additional things: model and the experiment. So let's learn a little bit more about what the model, the experiment is, and how it works with the whole data science part of it, and why should you even use it, and who uses it, and what does it all entail. So to do that, what we will actually do is create one of the simplest, uh, it's a machine learning or a data science experiment that anybody can possibly think of. So I'll start with a new notebook. I'll go to a new notebook, and I will add a lake house to my notebook, although we won't be, yeah, let's go ahead and I add my Portland lake house to this. And what I do is we will start creating the experiment. Now, for a moment, imagine that you are a physicist or a chemist, whatever you like, with a lab coat. Put your lab coat on, put your lab goggles on, and imagine you are in a lab and you are doing some sort of an experiment. What would you do in an experiment? You are doing something. If you are a scientist, you would go about doing that experiment very methodically, right? You want to identify if something is working. And the way you do that is maybe you have some hypothesis in your mind that it is working because of these five different things. Maybe it is because this. And we will do experiments with those five different things. And if any of those five things show the result that we are looking to see, then that proves one of those experiments is the actual cause of that phenomena, of whatever that effect is that you're studying, right? As a data scientist, you are doing the exact same thing. In this case, the notebook is your lab. Data is what you are trying to understand and trying to learn more about. And almost always you have some sort of an hypothesis, something that you are trying to understand, and something that you're trying to either prove or disprove. In case of machine learning, with the machine, as the name suggests, learning, what we are trying to do is understand the patterns in the data, and then from patterns of that data, we create a predictive model that we can predict something that would happen, so that for things that we don't know about, we will be able to use that to predict what will happen. Uh, and so to do that with the data science, what we do is, in this case, in Fabric, we use a Python library called MLflow. ML for machine learning, and flow is just flow because it's, it part of the entire machine learning experimentation or machine learning workflow. Yeah, there we go. Workflow. That's why it is called MLflow. So we will import MLflow, which is the library that we are using. So MLflow, I'm just saying import MLflow. And then I also say import pandas, the library which we use for importing data, analyzing the data in here. So I'll go ahead and then just import that in the MLflow library, as well as the pandas library. Notice that right here is session started in 4 seconds. This is because in Fabric, all of this is you are using the compute is already provisioned for you. It is always running in the background, which means you don't have to start the cluster. If you are coming from, let's say, Synapse, you would know that to start the notebook, it can take anywhere from 2 minutes to 5 minutes. In case of Fabric, I don't know how they did it, but typically it starts within 5 to 10 seconds, which is unbelievable. It's very, very fast, and it's just like that. So I've imported the ML flow library that I'm going to use and the pandas, and we need some data to play with, to do experiment with. And the data that I'm going to create here is, let's say, we just create something that is very, very simple, where I have just two columns here. So first column here is, say, maybe numbers that are from 1 to 10. I'm saying 11, so it's 10. And let me copy this and I'll show you. Um, and this is Y, and this is 11, and let's say 21. And if I show you the data, you'll see that it goes from, or actually, let's just see everything. I just have 10 numbers here that go from 1 to 10 and 11 to 20. And I have maybe another column here. Let's call that column as column Z, which is nothing but an addition of X plus Y. And let's take a look at that. So I have third column Z, which is nothing but X plus Y is equal to Z. Now, just for 5 minutes, just imagine that we don't know what Z is. We don't know how Z got here. But we are trying to identify what Z is, if there is any relation. If I just had X and Y, can I figure out what Z is, and which is what our experiment is going to be about? So how will we go about doing this? Go about doing this using data science and machine learning. So, like I said, we have to have some sort of a hypothesis, right? And my first hypothesis is that, let's say, my first hypothesis is that I create a function that accepts two values, and in return, it gives me P1 plus P2. Okay. Then maybe this is maybe not that. Maybe it is a subtractor. So I'll say subtractor P1 minus P2. Or the third option, you can have as many as you want, but for this one, we'll just say maybe the third one is a multiplier. So we'll just say mult. It accepts two values, P1 and P2, and it'll be P1 multiplied by P2. And then we'll confirm if any of that works. Now, as a scientist working in a physics laboratory, you will need to keep track of, you'll need to have your lab notebook, right? You will need to make notes. You'll have to take notes. Okay, I did this experiment first, and I added this and this together, and this is what my observations were, and this is what I'm seeing, so that when if something goes wrong, or if you need to reproduce that result or reproduce that experiment again, you can go back and then do that again. Or maybe you just need to publish it, right? Or that's just the protocol for your lab or for you to do that. So in here, we will do the exact same thing. What do we need to do? We need to create the experiment. So we'll say mlflow.set experiment, and the name of my experiment is going to be, I don't know, we'll just call that um, yeah, a Portland Fabric user group. And we will create that experiment and says, okay, our Fabric goes there and says, okay, I did not find this experiment name, but then it did not find that, so it went ahead and created that. If I go back to my Portland workspace here and then just refresh this page one more time, you'll see that we have this experiment with the experiment here with the flask here, right? Because we are literally doing an experiment. If I click on it, you'll see there should be nothing in it because we have not done any experiment yet. We just started doing the experiment, but we haven't done any experiment yet. So next, what do we need to do? We need to run some experiments and we run something, right? Where our hypothesis is that maybe it is probably one of these three things that is, which is what this Z value is. So let's do that. So we need to start the experiment, start the running the experiment, right? So I'll go with mlflow dot start run, and I'm going to name this experiment as run name. Let me do this. So start run. I think it is run name. is equal to, let's say my first one is an adder. And then what I'm going to do is P1 is my first value. So I'll just take the first or maybe fifth, let's say 6, 16, and 12, right? So I'll do my P1 value is 6, my P2 value is 16, and my result, the Z value, we will calculate that. But my result that I want to see is this. I'm going to use this is my first hypothesis, right? Adder is equal to P1 plus P2. So I'll go here and then say adder is equal to P1 plus P2. So which should result in 16 plus 6 is equal to 22, which is what this result should give me. But how do we know if we are on the right track or not, right? We don't know if I get 22, if it is the right value, or if I get 32, that's the right value. Well, in so there are two types of machine learning algorithms. First is supervised machine learning algorithm, and second is unsupervised. Supervised meaning you already have some data for that you can validate it against. Um, Example being, let's say, take an example of spam that you get in your Gmail, right? That you get a spam in your email, and then you click on spam button, and then Google knows that the user marked it as spam, and it assigns the boolean to that it is 1, meaning it is a spam. And then they look at everything, and they know out of all of 100 million or 100 billion emails that they have, out of those 100 billion, maybe 20% of those people have marked this as spam. So we know exactly what is a spam and what is not a spam. And Google can use that to figure out, okay, what is a spam and what is not a spam based on the patterns in the data. Same thing for us. We already know the Z value, that what it is, and we know in this case that Z value is 22, which is what we are shooting for. So how do we know that we are right? Well, we can calculate, right? I can do that 22 minus this result. If that number is 0, then I'm right, right? Then that matches my error is basically 0, so I'm on the right track. But we need to take notes, right? So we will take notes, and I'll say, okay, MLflow, let me log this value. So I'll say MLflow log param, and my first value parameter that I want to log is P1, because we need to take notes and because we need to make sure that we are able to reproduce this experiment later, right? So I'll go P2, and then this is P2, and then I need some metric meaning the error that we're talking about, to make sure or understand if we are going in the right track or not. So I'll go mlflow.log metric, that tells us if we are doing what is our goal. And our goal is, let's say, my log metric is here is error is 22 minus this result. Okay, and then all I have to do now is, if I run this and if I've done everything right, it should just take a couple of seconds. That ran successfully. If I go to my experiment now and then refresh, you shall see that I have my first experiment or run that I created, the adder. And what does adder have? Adder has P1 value that I logged 6, P2 value that I logged as 16, and then the error that I got was 0. But we have few more hypotheses that we want to run. So I'll just copy them and then paste them over here. And let's call this one as sub, and this is exactly going to be adder. This is sub, this is going to be my mult, um, and this is going to be my mult, and we are tracking the exact same thing. I'm giving the exact same values and then tracking what my error is. Now if I run this, I need a sub, not run this. It took 3 seconds. If I go back here and then refresh this, I should have one that failed because of that error, And then I have another one where mult, sub, and adder. So three runs are experiments that I created, three experiments that I ran, and then the values. When you are working with a machine learning project, typically speaking, in this case, we had two parameters. But in case of a machine learning algorithm, you have possibly hundreds of parameters. There are 100 different levers you can think of that you can adjust all at the same time to get accurate predictions. At the same time, you don't run that just one time like what we saw. You usually run them hundreds of times and thousands of times, so which means in a typical machine learning experiment, you will get thousands of these runs that will accumulate right here, which makes it very difficult to understand which of these did is the best, right? You need to be able to compare that, which is where this compare run comes in. I can click on the view here, and then I can select, I want to compare this, um, and then this. And what do I want to compare? I want to compare the errors for these three experiments that I ran, and these are the results. I'll see for the adder, I have a zero error. For my subtractor, my error is 32, and for multiplier, my error is minus 74. The number that I'm looking for is zero. If the error is zero or as close to zero as possible, then that tells me the ground truth that I have, which is the z value, the actual z value that I have, the function that I created is close to that. So which means adder is what is my right solution. And no matter what, how complicated your machine learning project is, this is the workflow that you will always follow. It doesn't matter what it is. The high level, you'll always start with data. You'll clean that data. Then you will create the experiments. You will identify 3, 5, 10 different types of machine learning algorithms. So there are different types of algorithms. So there is um, the decision tree. There is a regression classifier. There are XGBoost, LGBM. Yeah, lots of different ways to basically create these predictions based on the type of data you have, the structure in the data, your overall goals, and all that. And that's what I guess that's where the experience of the data scientist comes in. That what do you which algorithm you pick, and then what error metric you use and what parameters you change to get the best possible algorithm for your prediction. And then once you've done that, you'll come here, compare, and then identify. And now we have found adder is what we are actually looking for, right? So which means going forward, if you gave me uh, x and y values, I should be able to predict my z value with a zero error, 0% error, right? But how do we do that? I just created this and I created this function over here. But what I need to do is for my future Power BI reports that I'm going to create, where I'll have the x and y values, I want to be able to predict that z value. And we can do that by logging this model that we have, and then creating a model out of that. And the way you do that is basically, I'm just going to copy and paste a code here. All this is doing is we are defining the schema that my input that I'm going to use is P1 is going to be a double, my P2 is going to be a double, and my output will also be a double. And then MLflow expects it to be in a certain format, which you can basically just copy and paste from MLflow's website. And there's nothing fancy going on over here. And the same thing, P1 plus P2, and then I'm calling my model as adder, and I'm creating a new experiment that says adder with signature meaning what is my schema. Okay, so I'll just run that, and if it runs successfully, we should see in so that ran successfully. If I go to my experiment again and then refresh that and refresh that one more time, I will see this. And in this one, um, for the previous ones, we did not log any models. We did not have a model. We just created the experiments. In this case, the last one that we ran, we actually created a model, a machine learning model, which is this ML model. And it has ML flow packages all of that for you the way it's supposed to all work. You don't have to do any of this stuff and do that. Now, here is the nice part about Fabric. The whole thing that we just went through, creating, creating this ML flow dot start run and then signature and then logging model and all of that, you actually don't even have to do any of this stuff because if you go to the workspace and the workspace settings and then go to data engineering, go to Spark Compute, you will see right here automatically track machine learning experiments and models. It is always default, by default, it is on. So what that means is there are certain Python libraries. For example, there is one called scikit-learn that's mostly used, LGBM, there is XGBoost, there is PyTorch, there is TensorFlow, H2O, and all these different libraries that like all the companies use. If you use those Python libraries, MLflow has direct integration with them, and Fabric has auto logging turned on automatically. Meaning, if you use that, it will automatically generate experiments for you. Not only that, it will track all the different the parameters that we were logging earlier. It will log all those parameters for you, and you won't even have to do all of this stuff. Now, as you gain more experience, you will want to fine tune that and what you want to log and not log, and all of that stuff. But Fabric does all of that for you out of the box. Now, you may wonder why exactly we should even care about all of this stuff, right? Why not just use that and then calculate the error and then say to that? The reason again is in a typical machine learning project where you're creating all these models, you work with thousands of these different runs and hundreds of different models, and you're comparing all them together. So you want to be able to manage all of that. Second, data changes. So which means, let's imagine today it is my z is x plus y, but for unknown reasons, for whatever reason, um, business changes, there is recession, and now my x plus my z is not x plus y, but it is maybe x plus 2y. So what a data scientist will do is they'll have to go back, run that experiment with the new data, and then see what results they get. But for them to be able to do that, they need to be able to go back to when the experiments were actually logged, right? So which is where all this logging part comes in. They'll come here, they'll identify exactly which experiment was run, which you can identify from here. So if I go ML model, you will see it has the model UUID, it has the run ID as well. So just based on the model, you'll be able to go backtrack that which experiment I ran, which notebook I ran, and let me rerun that again, and then figure out if I need to make any changes or not make any changes and all of that. And so that's why this ML flow tracking or this experiment tracking or model tracking is super important in machine learning. So you do all of that, and we added that, but we are not done yet because we created this adder. But if we go here, we don't see that adder model created here, right? And the reason that for that is what you need to do is go to this adder and then click on or this model and then click on save model. And then I'll say I want to call this as my adder model and then click on save. And it takes about 30 seconds or so for it to pop up. The model is successfully created. And if I go here now, I see my adder model is created. So I'll go here, adder model, which has all the things that I had earlier created. So if, let's say, imagine you are you are a not a data scientist, but you are a Power BI user, and your data scientist colleague has already created this model and has asked you that, hey, Sandeep, you want to create forecast, right? Well, I have a forecast model that I've created. Why don't you just grab that forecast model from the model registry, and then use it in your so that you can create forecasts like the forecast that we saw earlier here. Create forecasts and add that to your Power BI report. And for that to happen, you'll need to know basically two things. One is, what is my input schema, meaning what do I need to provide to the model to create that. And in this case, it's telling us I need to provide two columns. First is called P1. It is a double type schema, and P2 and a double data type. And out of that, I'll get a double a column that's called double. And then there are parameters that are not logged in this case, but there will be, and then some additional information. Now you need to use this model for your Power BI report, right? And you can do that, let's say, three different ways. You can directly invoke that model in your report here, or you can go to the model portion of this and say, apply this version. So we'll first look at it using the model wizard. So I'll click on this model wizard. I'll say it will ask me where is my input table where which I'll use as my input to the model. I'll say Portland workspace, and this is the table I have. I'll go to next, and it already identified that I have a column called P1. It could be different. It may be called T1. It doesn't matter, but you will map that here. I'll say P1 and then P2. In this case, it's already matched well for me. And it's where do I want to create a new table? And it is in Portland workspace, or it could be a completely different workspace. Let's say Portland. Lake House is my Portland, and new table that I want to call is, let's say, my Z predictions. And then click on next, and the name of the output that I want to create, and let's say it's called Z bread, and click on next, and it will generate the actual code snippet that you need to use. So I'll just grab that, copy this to clipboard, and this part is done. I don't need to do it. You can create a new notebook here from here and then use that, but this part is done. I'll copy this and I'll go back to my notebook here and I'll say um, model.transform. I'm not going to save anything, so let me cancel that out. And then this portion, I'll just say show so that we can see the output, and I'll just run this. And if all goes well, and if our experiments are successful, we should see that it will give me a Z prediction based on the P1 and the P2. Right? So, which is what the exact workflow will be if we were creating the forecast for this graph, where I already have the model that I had created. I'll save that model to my model to run the experiment, save that model to my model registry. And then when I want to use it, I can either use the code, the model wizard, or in fact, the other way of doing this is go to copy code to apply, which just basically gives you everything in here. And the only thing you need to change is the name of the table here, and then the output table. That's it. And then basically the exact same thing like what we did, but this gives you the output directly, the code output directly, whereas the other one walks you through the overall scenario here. So you do that, and then the final step here would be is We'll go here, and then maybe if we just want to comment this piece out, we can do that. So let's just run this part here. So which will create the delta table, and then save the predictions directly to the lake house here, which I refresh, and I have my Z predictions table right here, which it then can be imported into Power BI, or any other application that you have. So to recap for ML flow, the overall process is like you start with the data lake where you have the data, you clean the data, you train the data, which is where we created the functions. Once you are satisfied with your run, then you will save that to the tracking backend. Now, this tracking backend, if you're in Azure ML, Azure ML also uses ML Flow, so overall process would be the same. If you're using Databricks, you will also use ML Flow. You then out of that, you will track all your experiments. You will review your results, save that model to the model registry, the final model to your registry, and then you deploy meaning you get the results out of that, and then you keep monitoring that for any data drift, or because data changes, right? Business changes, your economy changes, business conditions change, your data assumptions change, and all of that. So you need to be able to continuously monitor all of those things to be able to create more robust predictions for your business. So that's the machine learning, I guess, experiment part of it. Uh, s- yeah, so that's all I guess I had. So to recap, uh, the last piece that I showed here, machine learning, most people when they think about data science, they think about machine learning. But I really hope that with Fabric, what Power BI did to business intelligence, where it really democratized um, data science, Fabric will do the exact same thing with data science, that it will be able to democratize BI, and give tools that all the business analysts and data analysts never had. They wanted to, but they never had. And then create more business insights for their users, enrich and augment the Power BI reports, and then use that in their overall workflow.
Yeah. Sandeep, I
So
think one of the
yeah,
most important things too is working off the same data,
yeah,
right? Like I feel like
exactly. Working
data
off of the same
scientists were
data.
like squirreled away, BI analysts were squirreling their data away in different places, right?
Yeah,
And now we have a singular GUI, we have a singular lake house to work off of. And
correct.
so there's less, stepping on each other's toes, or you got these numbers or I got those numbers.
And I have run into those scenarios many times, where a simple example of that is this looks very simple, right? If I go here, this looks very simple where I say net sales is this. But we as business analysts, we know it's not that easy. When I'm calculating net sales, I have three different filters in my DAX defined, where my account is not intercompany, where my department is this and this, where and all of this. And all of those are defined in my DAX measure, and that's how my actual net sales is calculated. When your data scientist calculates it, now there is a disconnect. If that definition of the net sales changes, then even though the data scientist has created the model, you are actually using the wrong model for the data that you have, because his assumption is completely different from your assumptions, right? So to Greg's point, those two things are completely different. Now, the way, um, I guess we'll learn more about it very soon, but I think it would be safe to, I guess, talk about it, because I saw Justina talked about this in one of the podcasts last week. There is something more called semantic link. I don't know if you guys have heard about that, but s- as a part of Fabric, Microsoft will be launching another thing called as Semantic Link, which will be which will allow the data scientists and the data analysts be able to um, speak to each other. Uh, uh, I guess communicate those measures with each other easily. Meaning, if you have defined a measure for this in my Power BI measure that I've created here, you can pull that measure using Python inside of Notebook and query that inside of Notebook. Meaning, the thing that I went through here.
So you can like
Uh,
reconcile like what the machine learning model is giving you versus measures in a report, or
Both. So what I
oh wow.
can do is think about it as a your semantic layer, and semantic layer has the definition of what, let's say, net sales is, right? Me as a data scientist, if I want to calculate net sales, I'll have to go through all the steps of applying the exact same definitions all over again using Python, right? If that definition changes from what the definition you have in your DAX measure, we are off. Then there is no way for me to know what you have defined, and there is no way for you to know what I have defined. But with the semantic link, you will be able to directly go to that measure and grab that measure, and then use that in the notebook.
Wow.
I
So
think
it's gonna literally write the Python and all the underlying pieces for you, or wow.
Well, I mean, we won't go into the details. I think, Justina, if you look at, um, so Justina talked about this. I think whose was on a podcast like just last week. In fact, Nelly Gustafsson, who's the PM for the data science team at Fabric, she also talked about it during the launch as well, where you will be able to, uh, just use you'll be able to use your measures and your columns from your data set, Power BI data set, using Python, and then vice versa. So that
Wow.
way, yeah, you won't be able to, you won't step on each other's toes. It will be much more fluent, and it all will come together as you define it to one single place, and you have your data in one single location, and all you have to do is just go grab it and create your solutions based on that.
Well, honestly, huge kudos to Justina. I mean, I
Oh
remember when
yeah.
she was just doing like AI visuals, and she's just
Yes.
been promoted and promoted. And
Oh yeah.
to do this with
Unbelievable. Yeah.
Semantic Link, I had no idea. I've been kind of heads down on other things. I haven't heard of that, but that is game changing for
That
sure.
is game
I mean, who
changing. I
else
mean,
is doing
it
that?
goes significant. Exactly. There is nobody in the industry right
Nobody's doing
now
that. Nobody
who
cares to do
has
that.
anything close to this. So Justina and I met before, well, like 2 years ago, when she took over this project of what back then was Tried and Tried, just to talk about like what is it that the data scientists need to do to understand Power BI and Power BI. And I obviously at that point I didn't know anything about any of this stuff, and I just explained to her what I would like to be able to do if I had a magic wand is be able to use the same data in a notebook that I'm using in Power BI, and then all the measures that I have be able to explore and query those measures directly in my Python. So we are all living in harmony, and everybody has visibility into all the measures and all of that. And 2 years later, it's a reality. I mean, it's just a testament to what Microsoft has done, what Justina has done, and the entire Fabric team has done. So yeah, I'm very excited for the semantic click thing.
It's amazing. Yeah, I was just we're pinging in the chat. Yeah, Justina had presented with us back way back when we had a when COVID hit, and we had a virtual,
Mhm.
session. I mean, I met Justina. We did a project with her when she was trying to promote Q&A, and they were
Oh,
just
okay.
building out Q&A. So I got to work, directly with Justina, and she was pushing updates to Q&A in the monthly Microsoft update specific for our customer.
Mhm.
It was wild.
Yeah.
So again, it's seeing, I think that was like 4 years ago, you know? So that, again, huge kudos to her. And, between her and Mark, they're the reason why Fabric is going to dominate.
Yep, absolutely. So the podcast
Cool.
that I was talking about was actually on Casper's podcast. Yep, all about Casper on BI, where Justina was there just a couple of weeks ago. So definitely take a look at that. Let me just make sure. Yeah, right here. So data science, and Justina talks about that. She talks about how she's excited about semantic link and what semantic link will be able to do, and all of that. So I'm very excited about how all of this is going to come together.
Awesome. Well, Sandeep, this was one of the most in-depth I've seen on the data science side of the world with Fabric, and I'm sure everybody on this call has just learned so much. And so thank you for taking the time with us, going into detail and walking from end to end. And of
Thank you.
course, feathering in these new capabilities that are coming up. Man, I'm sure this recording will be watched over and over.
Thank you.
Thank you so much, Sandeep, and everyone else. Thank you so much for joining us for
Sure.
yet again another wonderful user group.